Okay, hello everyone. I apologize in advance if you hear a little kid screaming. It's my son. So I'm going to go through this review that's always at the end of your notes. And why I'm doing that is because I feel like it's a good example of each problem that would have been in your notes. And instead of doing a lesson every single day, this video will just give you a good overall indication of probability. So let's start with the top. It says a bag contains 3 white marbles, 2 black marbles, and 5 red. Find the probability for choosing a marble that is not red. So first of all, I would encourage you to try looking at this and seeing what you could do, because some of this is review. Or trying a problem and then playing the video, pausing it, trying the problem, rather than just watching it and copying. So you have a familiarity while I'm going over it. Now, this is basic. It's saying there's 3 white, 2 black, and 5 red. So that's 10 marbles. They're saying how many are not red. So 5 are red, that means 5 are not red. Another way you could write this is saying, what's the probability that you do not have a red marble? Or what's called is its complement. So if I'm finding not red, it would be the complement of red. So that little C means complement. So that would be 5 out of 10 marbles, 3 white, 2 black, which would be 1/2 or 0.5. And so I really encourage you to write it also as a decimal as well as a fraction. Probability is from 0 to 1, 1 being 100, 0 being impossible. So you will start to see when you're reading data or information or journal articles that they write probability not as 50%, but 0.5. Okay. The next one is follow the number of possible passwords. So there is what's called the fundamental counting principle. Sorry, my battery hit. And what that says is if you have m ways to do something, and then you have n ways to do something else, you have m times n ways overall. So if I'm trying to find a password that has 2 letters and then 4 digits, how many ways can you do this? Well, how many letters are there in the alphabet? There's 26. And then they didn't say they couldn't repeat. So you have 26 letters to choose from again. So you could put like D, F. And then digits. Well, 0 through 9, that's 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the numbers could repeat. You could have 1, 1, 1, 1. So you put all your options down. So I have 26 ways to find the letters, and then 26 more, and then 10, and then 10. Well, the fundamental counting principle says that you can multiply all of your ways together. So that'd be 26 to the second times 10 to the fourth, and you can put that in your calculator. That's 6, 7, 6, 0, 0, 0, 0. Okay, so 6,760,000. The graphing calculator, if you're using it, will probably give you scientific notation. So just do 26 times 26 and add on 4 zeros. Okay, and then same thing with the next one. The order doesn't matter because you're multiplying all your ways together. So if they say 2 digits, 2 digits and 2 digits, you don't have to put them in this order, but I'm just going by what the problem says. So it would be 26 to the third times 10 to the fourth, which would be 175,760,000. Okay, so that's really day 1 of this lesson. Is basic probability and fundamental counting principle. So what's the difference between probability is how many ways, or in how many ways is how many ways is just a straight up number. It's just saying X amount of ways. Probability is saying how many ways out of possibilities. So probability will always be a fraction and options are just a number, okay? So if they ask for probability, you better give a fraction or a decimal. Okay, so number three would be part of that as well. It says if one point is randomly selected from the points inside a rectangle shown below, find the probability to the nearest percent. So if I were to take a dart and throw it, what's probability it would land on one of the circles? Oh, it says the shaded area. I apologize, the shaded area. So what you'd have to do is find the probability of the not circle. Okay, it's complement. So it'd be easier to find the circle than the shaded area because this is not a good shape to find. Circles are easier. So how do you find a circle out of the total area? Whatever that probability is, remove it from 100. So say to find the probability of these circles would be 80%, then the complement would be 20%. So I have two circles, and to find the area of a circle, it's 2 pi r squared, and I have two of them. And then your total area is a rectangle. Well, if the diameter is 10, that means your radius is 5. And that means if the diameter is 10 this way on a circle, it's also 10 this way on a circle. So 10 and 10 would be 20. So this entire area is a 20 by 10 or 200. And then we just said the radius is 5. So when we do that, that would give us 25 times 2 or 50 pi out of 200, which reduces down to pi over 4, which is about 0.7854. So it's about, well, what do they want it to? They want it to the nearest percent. Okay, so if this is about, we'll say 79%, then the probability that it's not the circle would be 21%. So that would be your answer because they want it to the nearest percent. Okay, so if that was too fast, rewind it, pause. Okay, try it on your own. All right, now we're getting to the next unit, or the next day, I should say. Permutations and combinations. I'm gonna kind of hold off on this until we actually get to a problem with permutations and combinations, because if I do these formulas, it's not gonna make sense to you. Permutations is where order matters, and combination is when order doesn't matter. So for example, student council is holding elections for president, vice president, secretary, and treasurer. If 20 people are running for office, how many possible outcomes are there? So I have 4 positions. Order matters because if I pick a president and I pick a secretary and I swap them, it's gonna make a difference. So order matters here. So we're gonna say P for permutation. Okay. So I know that I have 1, 2, 3, 4 spots. So there's 20 people, and out of one of those people, I pick a president. So I had 20 options for president. And once I pick the president, then I have 19 left, and then I have 18 left, and then I have 17. Okay, so if I multiply those ways together, I get 116,280. Okay, well, you're gonna learn in those notes that this is almost a factorial. A factorial is when it would be like 20, 19, 18, 17, 16, 15, 14, so on and so forth. It would be if I had 20 people and I used all 20 people. Here though, we have 20 people and I'm using 4. I'm not using all 20. So it's kind of like saying 20 factorial. And how you write 20 factorial is 20 exclamation point. That means 20 times 19, all the way down to 2 times 1. But we don't have that. We have only to 17. So that 16 factorial is gone. Okay, so the formula for a permutation is I could have used 20 factorial, but I don't have 16 factorial. So I have 20. 20 minus 4 ends up being 16. So what you say is I have 20 factorial removing the 16 factorial. That's another way to write it. You could do logic. You could use the formula, or you could use your calculator. You would literally type in your calculator 20, and then you would go to the probability button in your calculator, and you would hit NPR 4. Okay, play around with your calculator. Let me grab mine. I think it's downstairs. But it's either on the math button or the stat button for statistics. Okay, I can't think off the top of my head. When it's not in front of you, it's hard to think of. Okay, so let's try it with here. You could use it in your calculator or use the formula. So what this is saying is it's 14 factorial over, we subtracted these two. So subtract these two, 14 minus 0 is 14 factorial. You would get 1. Okay, and this is saying I have this many ways to do one thing, and then I have this many ways to do another. What would it be? This would be 4 factorial over 4 minus 2 factorial times 7 factorial over 7 minus 7 factorial, which is 0 factorial. And you would get 60480. Well, what's 0 factorial? If you put in your calculator 0 factorial and press enter, it will tell you 0 factorial equals 1. And why is that? Well, I'm going to attach an awesome YouTube video of, it's called Number File, and they're British and they're really, really funny. And they're going to explain why 0 factorial equals 1. But they said if you want to think about it philosophically, you can think, how many ways are there to arrange 0 objects? There's only one way. There's nothing. They show a more mathematical pattern way to do that, and I will put it in with all the other stuff. All right. Move on to combinations next on the next page. It says Tajane likes to mix different juices with her breakfast. There's 8 juices to choose from, and she wants 3 flavors in her drink. So she has 3 flavors. And she has 8 to choose from. Now this is a combination because, believe it or not, order doesn't matter if you put orange juice, grape juice, and apple juice. So if you did orange juice, grape juice, apple juice, orange juice, apple juice, grape juice, apple juice, orange juice, grape juice, apple juice, juice. Here would be all the options. But technically these wouldn't matter because they're all the same thing. So we would just do this like we did before. I have 8 juices to choose from for my first juice, then 7, and then 6. And you multiply them together. However, these 3 ways don't matter. So you'd have to remove them. So the 3 times 2 times 1 way. So if I picked orange juice, let's say, and then apple juice, and then grape juice, these 3 juices, 3, then 2, then 1, those 6 ways wouldn't matter. So what I have to do logically is say, okay, 8 times 7 times 6, and divide by 3 factorial. So combinations is a little more intense. You could use logic, and I encourage that because you'll remember it a lot better than using a formula. The formula would have been, remember, 8 factorial, but we don't have 5 factorial. So if I have 8 juices and its combination, and I'm only taking 3, 8 minus 3 is 5 factorial. But then, hey, wait a minute, if I'm choosing 3 juices, those 3 times 2 times 1 ways don't matter. It's a lot. So logic, formula, or you could use the calculator, okay? And you're gonna get 56. Now, combinations, you're gonna get a lot smaller amount because you're trimming the fat. You're removing all these other options that are essentially the same because order doesn't matter, okay? We're gonna do a few more, and then I'm gonna cut the video in a little bit to do a part 2. It says a car dealer has 8 exterior colors, 12 interior colors, and 7 options. And how many different ways can you select? Well, you could just use fundamental counting principle and say 8 times 12 times 7, and you would get 672. But order doesn't matter when you're picking out colors. So if you're like, I get confused going from combinations or permutations, you could say it this way. I have 8 exterior colors and I'm choosing 1. I have 12 interior colors and I'm choosing 1. And I have 7 and I'm choosing 1. And you could do it that way as well. And you get 672. Order doesn't matter here. Either one, fundamental counting principle or using combinations. A bakery has 6 different kinds of cake and 12 different kinds of pie. If DJ and Zoe come to this bakery, how many different ways can they select 3 cakes and 4 different types of pie? Well, does it matter how you select a cake or a pie? No, it doesn't. Okay. So if you have 6 cakes and you're going to take 3, order doesn't matter, you use C. And if you have 12 kinds of pie and you're taking 4, order doesn't matter, you're going to use C. And then fundamental accounting principle says if I'm choosing this many ways to get a cake and this many ways for a pie, then you multiply them together. You could just use your calculator. And then you would get 9,900 ways to choose the cakes and then the pies. Okay. And then lastly, Tyler has 20 movies and 12 video games. Matt wants to borrow 5 items. What's the probability? Okay, so it says probability, we need a fraction. He will choose 3 movies and 2 video games. Okay, so we have 20 movies. Order does not matter when you're choosing a video game. So we're going to go to C. And we're going to take 3 movies like it said. And then we have 12 video games. And we're taking 2 video games. Okay, so when you multiply these ways together, you're going to get an amount that you want. But they want the probability, so it's got to be out of the total amount. Well, we have 20 movies and 12 video games, so that's 32 games and movies total. So probability is always out of your total. And we are using combinations. And we're taking 5 items, it said. So these numbers will always equal this number, and these numbers will equal this number. When you do that, you'll get 75,240 over 201,376. Okay, which will reduce, and then you can make it into a fraction, which is about, decimal, 37%. Okay, also going back up here, this top number will always equal these 2 when you're dealing with combinations. And if you go back to that first page on the front, let's go back to the combinations. Okay, it would be 25 factorial. 25 minus 10 is 15 factorial. But then that 10 that we're choosing, we have to get rid of the 10 factorial. These numbers will always add up to the top. Okay. That's it right now for permutations and combinations. I know that that's a quick lesson, but hopefully you've been learning it on your own in the notes. We're going to take a break, and then I'm going to post part 2.